Today we're going to talk about the periodic table. In order to talk about the periodic table, we gotta understand how matter behaves. Matter behaves like waves. You and I are both waves, believe it or not. We both have a wavelength. But if we are both waves, why aren't we fuzzy? That's because our wavelength is so very, very small and that we can't see it. Elementary particles, on the other hand, the building blocks of atoms, have a relatively large wavelength compared to their size. In essence, they're fuzzy. Electrons, therefore, are waves and behave like waves in their properties. In high school, you might have learned that electrons orbit a nucleus. This is, however, incorrect. Electrons cannot orbit the nucleus due to an attraction force that in essence is like gravity in our solar system. If electrons were guided by this orbit system, or this solar system model, they would eventually crash into the nucleus. This cannot happen, so the Bohr model of the atom, the solar system model, is incorrect. Therefore, we have to treat the electron as a standing wave to understand the periodic table. Waves have nodes. You might have seen this in graphs of wave functions, etc. These are three-dimensional waves, though. So to get a grasp on a picture of how waves behave, let's think of in 2 dimensions. Waves are in 2 dimensions are kind of like a drum head, that they'll have a positive side and a negative side, and they can also display angular nodes. These nodes are very important to our discussion of the periodic table. As the electron wave has more nodes, this corresponds to a farther distance from the nucleus. As we'll see when we look at the periodic table later on, as nodes increase, the atomic radius will increase as well as it gets farther away from the nucleus. There's still a weak attractive force between the nucleus and the electron, and this corresponds to the principle of why electrons will fill orbitals or will have waves closer to the nucleus rather than further, because there is that still weak attractive force. Because of this, that they want to be closer to the nucleus, this corresponds to lower energy levels. That it takes more energy to have them further from the nucleus. And so they'll fill lower energy levels first. These lower energy levels correspond to the number of nodes. In high school, you might have learned electron configurations. And so helium has a 1s2 configuration. Oxygen has a 1s2, 2s2, 2p4 configuration. The numbers correspond to energy levels, while the S and P correspond to orbitals. You might have seen a graph similar to this, to how the energy levels work in high school. This shows how electrons fill their orbitals. That in helium it is a 1s2, whereas in oxygen we go 1s2, 2s2, 2p4. Okay? The number of electrons in each orbital is dependent on the number of nodes in the waves. As we see here, 0 angular nodes and one total node corresponds to the S. As we increase the number of nodes, we have a repetition of 0 nodes as a possibility of how the electrons fill. However, we start having angular nodes as possibilities as well. The number of angular nodes corresponds with different electron orbitals. 0 angular nodes, as I said, was S. 1 angular node will be P. 2 will be D, and 3 will be F. This corresponds to how, back to our other table, This corresponds to our energy levels again, how that they will fill different orbitals. Going back to our discussion, in order to talk about periodic trends, we first have to learn the concept of valence electrons. Valence electrons are the electrons on the highest energy level, so the highest number in front of the orbitals. The p orbital, as we saw, can hold 6 electrons, and the s orbital can hold 2 electrons. Therefore, as they will always correspond with the highest number, we can only have 8 valence electrons in each orbital. When we look at the periodic table, we will see that the valence electrons describes the structure of the table, that the highest number corresponds of S and P corresponds to different properties that the atoms will have. Like the halogens all have 7 valence electrons, and noble gases have 8 valence electrons, or have a full shell of valence electrons. Let's look at the periodic table so that we can see this. As we can see, that this corresponds to 1 electron in the s orbital, with 1 electron level, the second energy level, the third, the fourth, and so on. Over here we have electrons filling the p orbital in this section. This will become the d orbital, and this will become the f orbital. Remember that this is 0 angular nodes, 1 angular node on the p section, 2 angular nodes on the d, and 3 angular nodes on the f, where each energy level corresponds to 1 node, 2 node, 3 node, and so on. We can start talking about trends in the periodic table now. So, as I talked about earlier, atomic radius is determined by the periodic table. Remember that as electrons become further away, or have more nodes, they become further away from the nucleus. That means the atomic radius will increase. Although as this happens though, as electrons fill the shell, or fill the orbital, the atomic radius decreases because of the attractive force of the electrons in that orbital. Therefore, the alkaline metals will have the highest atomic radius of each row of the periodic table. We can talk about electronegativity as well. You might have learned in high school that fluorine is the most electronegative element. This is because that it has 7 valence electrons next to its nucleus in the lowest energy level. As we decrease in the halogens, the electronegativity decreases. This is because of a shielding effect, that as the radius gets increases, the shielding effect, that the electrons can be easier taken from the element. And so, as if you did not know, electronegativity is the electron, or the affinity of an atom to lose an electron. Same with ionization energy, that the ionization energy, the highest is helium, followed by neon, and so on, and it decreases as they rose. This is the likelihood that an electron is going to be lost by the atom. This means that it will have a highest energy at helium and neon, and decrease as we go down the table. This is also due to shielding effects. Do you have any more questions for the periodic table? If not, that's all we have for today.